Good morning, good morning, guys. And today our topic is activation functions of neural network. You can see this is the activation functions. Means whenever we apply some neural network, then we have to apply some program. This program or code is called activation function, and depending on this activation function, a neuron and getting activated or does not activated. We will go for the details. Then you can see how does this neural network become activated or deactivated it or inactive really. And this way we can make a decision making program. Look, activation function decides whether a neuron should be activated or not by calculating weight sum and further adding bias with it. Okay, means activation functions yields the permission to a neural to a network of in any neuron that whether it will activate it or does not activate it, means remain inactive. The purpose of activation function is to introduce non-linearity into the output of the neuron. Okay, we will discuss about the non-linearity or linearity. Say in our program, in your normal conventional robotics program or Arduino program, we are doing just straight condition, just like linear condition, just like if and else. If there is a one, then we'll go. If there is a zero, then will not go. But there is not mentioned if there is a zero point 0.5 is there or tends to 0, then what will we do? And if there is a tends to 1, what will do? There is no certain mention. So this is the decision making capability. Say if the equations are linear, then we are just doing just like a robotics application, just like a robot. Not it will not say any smart, but each and every program, if there is some between 0 or 1, means there is on or off, then we have to decide whether we select it 1, whether we select the 0. This is the main topic of the decision making. Say if it is the 5 volt, then you select this is 1 for the microcontroller. If there is below 5, means anything 0 to 4.9 volt, then it will select as a 0. Okay, or you may say this is if there is a 5 volt, there is 1. If it's 0 volt, then it is 0. And somewhere if we select this program, then if the input is coming 4.5 volt, then also it is selected as the 0 or treated as the 0 because it is not crossing the 5 volt value. Okay, so this is a straightforward linear program. Okay, it has no decision making capability. But in the linear in a non-linear programming, non-linear conditions, say if there is a 5, then 1. If there is a 0 volt, then it is 0. But if it tends to 5, means above 2.5 any value, then also it is selected 1. And if the value is in front inside of negative section, say negative terminal, then it will maybe anything, it will treat it as the 0. Okay, so in between this 0 and 1 level, they also decide or also some program is there so that it can select next one. And this is I will explain this in the sigmoid curve. Okay, then you can understand with a real example. But now it is the main artificial neural network, which is generally smart. It is called smart. Why this is smart? Because it has some decision making capability, and this is the function, this is the nonlinear functions which helps a neuron to be activate or remain inactivate remain inactive. And in this way we can make a decision making capability. Okay, for an example, we can say, look, we know the neural network has the neurons that works in correspondence of the weight and the bias. Okay, and they are respective activation functions. In a neural network, we would update the weight and bias as of the neurons on the basis of error at the output. This is known as the back propagation. Okay, the activation function makes the back propagation possible since the general gradients are supplied to supplied to along with error to update the weight and the bias. This is the main activation functions. Okay, or now we are going to rather theory, we should take a example also. Okay, look, this is the neural network, this is the bias are added such just with this, and this is the w1. Look, in the layer 1, z1 is the w1 and means weight 1 plus into x and the b1. Okay, and a1 is the z1. Okay, a1 is the z1. Now what are this? Look, z1 is the vectorized output of the layer 1. z1 is the vectorized output of the layer 1. Okay, so the in this case, in this here, okay, and w1 is the vectorized weight it assigned to the n neuron. Okay, assigned to this neuron. If it is going to the in point and this input to the h1 layer, this is the hidden layer, then it is w1. And if this is going to in this way, then we have to assign this is w2. So here is the differentiation, and x is the vectorized input, this is the features as I1, and this is the I2, this is the input. Okay, whatever input we are giving, this is X. B is the vectorized bias. This is vectorized bias. Okay, B1 and B2 means something is added. Okay, whenever output is given, then we have to add it something. And A is the vectorized form of any linear function. Is the vectorized form of any linear function. Means after this is it's become the linear. Okay, so first this is the layer one. Layer one is the z w1 into x plus b1. Here is the up to this. Here this it is coming. Okay, then after this the layer two. Okay, so the layer 2 input for the layer 1, this 2 is here. So Z2 is the W2, Z2 is the W2, and A1 multiplied with A1 plus B2. Okay, this is the layer 2. And this is the A2 is the Z2. This is the output over here. So calculating this, Z2 is the W2 into multiplication W1 into x plus b1. This is the coming from here, and here in this case here plus b2, this is bias 2. So z2 is the w2 into w1 and into x plus w2 into b2 plus b1. So this is b1 plus b2. Okay, then we are going to the next. Let W2 into W1 it is equal to W1. W it is assumed. So W2 into B1, just W2 into B1 plus B2 equal to B. Now find out the Z2 is the W into X plus B. Look, here we are not where we are seeing the last step, it became a linear. This is a linear function. So you can see this is coming in the nonlinear activation functions, but in here at here this is became the linear function. Okay, that is it is showing here. Now we are talking about an example of a sigmoid curve, how neural network takes a decision. Okay, then we are going to the word formation. Look here, paint. Okay, so guys, you can see there is some sigmoid curve. Oh, sorry. Guys, after that you can see there is so many functions, but I am talking about sigmoid curve. Look, this is the sigmoid curve. Sorry, it is in this way. This is sigmoid curve. A graph is given as a S graph, and you can see this is the sigmoid curve. If we do this, actually it is going to the upper position. So upper position. Yes, this is the sigmoid curve. You can see. I just look. This is the sigmoid function, and the value is, say this is the value is, that is 1, and this is the value is -1. Okay, and this is the 0, you know. So if there is a value is coming in this way, it is selected 1. Say in any value it is selected 1, and if there is a any value regarding this -1 section, then it will select as a 0. Okay, so not only one, if the say voltage level is 5, say this is 5 or 0 or anything is -5, or it is coming the +5. So any value between this 0 to 5 volt, or any value 0 to 1 volt, this is for the case 1, this is for the case 2. Anything, it may be x, it may be x, it may be y, -x -y. So any value from the positive side, it will take 1, means it will activate, okay. If we activate, I could not write properly, activate, and any value after 0 and -volt, anything, it will get 0, means not inactive. Okay, so what happens, say we are talking about decision making capacity, for you are writing a handwriting, which is you have written a 1, but how could I select that is 1? Say in this board there is some pixel is there, say a photography detection. This is 1, this is 1 1, this is 1 2, and this is 1 2. Sorry, this is horizontally, okay, horizontally 1, horizontally 2, and this is vertically 1, vertically 2, in this way. Say you have written 1, someone handwritten is 1, this is 1, okay. Some can written 1 in this way, okay. Someone can written handwriting 1 is here, But computer, how could it recognize that this is one? Some can retain in this way, some input is coming in this way. So in between, this is also a one, this is also a numeric letter one, this is also a numeric letter one, this is also someone is written. So this is the picture one, this is the picture one, this is the peak one, this is peak two, this is peak three, this is peak four, this is peak 5. So among these five picture, which one is numerical one? Look, we can recognize this. Yes, this is one, this is also one, this is also one, but these two picture are not one. Maybe this is also a single line. So we have to program in such a way that the neural network will activate. Guys, this is the fundamental things, and I think if you can understand, then neural network is very easy and very interesting also. Then just keep patience and look this. Look, one activation function is there, pixel is there. Say this is the pixel 1, pixel 2, 3, 4, and in this way 4, 5. So 16 pixels is there. So we have input layer, there is something, the 16 pixel is there. Okay, 1 2 up to this 16 pixel is there. We are nomenclature one, say this is 1, this is 2, this is 3, this is 3, this is 4, this is 5, this is 6, 6 is there, this is 7, this is 8, this is 9, this is 10, and this is up to this is 16. So 16 input layer is there. Look, in this way, which pixel are activated? Look, pixel 3, pixel 7, pixel 6 also, pixel 1, sorry, pixel 10, and pixel, this is 9, 10, 11, 12, 13, 14, this is 14. So 14 number pixels are we have written here. So look, this is the three pixel became activated. Look, pixel number 3 became activated. So 1, 2, 3, 3 pixel became activated. Then pixel number 7 and 6. 1, 2, 3, 4, 5. Here is 6. Here is 7 is activated. Then pixel number 10. Say pixel number 10 is here. Pixel number 10 is here. Then pixel number 14. Say 14 number pixel is here. Other pixels are not became activated. Okay. Other pixel over here, there is so many pixels are there. So many pixels are there up to the 16. But only this type of pixels are activated because we are getting some input value. Then it will given to the second layer. Then it will second hidden layer, first hidden layer, but it is a layer in seconds, and there may be so many layers. They are calculating or checking because some weighted is there. Look, they are checking means we have given in this here. Look, we put that if it is one, then at least three or two, three pixel in parallel way it should be activated. Okay, so up to this, there is a 1, 2, 3. At least 3 pixels in a vertical way, in a 90 degree way, that should be activated. If regularly vertical 3 is not activated, then it will not selected at 1. So this is 1, 14, 10, and this is 6. Look, 14, 10, and 6. This 14, 10, and 6. These are the vertical. Okay. So whenever these are 3 are activated, then it will select it as a perpendicular. Once it is getting perpendicular, they selected yes, this is 1. And if the fourth number is at least the this second or the first pixel, anyone may be first after or before any pixel. So here we are getting 3. If there is a 2, then perfectly 1, but it is not perfectly, because it is coming to the next propagation, next pixel. So anyone, if anyone is there, then it will be selected as 1. So this is selected 1. But how it is selected? Look, whenever it is come to this point, whenever 3 means above this input, so it is selected also 1. Whenever, look, very small portion is there, yes, very small portion is there, okay, but this is positive, so it is selected 1. uh, and this is, look, 6, this is also very small. If there is activated, then it will get, say, 1 volt. If there is getting, say, there is, it is getting point and 3 volt, 0.3 volt. But as it is positive side, they also select as a 1. So these pixels are, these neurons, are saying, yes, this is 1. It may be here or here, but it is selected as 1. So it is our, this late picture we selected as a 1. In this way, we can neural network take a decision. Look, another way, I am saying, another picture we are drawing. Say in this picture, you can see, say if here is some graphical representation, then we select some pixel. Look, in this case, say pixel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, this is 2, 2 is activated, 3, 4, 5, 5 is activated, 6, this is 7, 7 is activated, 8, this is 9. So in this way, all the pixels which are in the form a perpendicular, which is forming a perpendicular, it is activated. These 3 pixels, this 2, 3, 4, 5, 5, 6, 7, 8, and 9. These are the making a perpendicular formation. So once it is selected, then look, then it is, decision is taking, yes, this is the 1. But in the picture 1, picture 3, yes, this is also same case. But in case of picture 4, look, picture 4, if you judge, going for the judgment of the picture 4, you can find there is, this picture is not perpendicular in the form. Say if, so if a graphical representation sigmoid curve is applied, look, if we pick, if we yes, this is the graphical sigmoid graph. But here you can see only this type of pixel are activated, means this type of neurons are activated. Say this is this is, say this is 1, this is 2, 3, 4, this is 5, this is 6, this is 7, this is 8, this is 9, in 10, in 11, this is 12. So if there is a 12, we need a 12 neuron. First we have need a 12 neuron. So neuron 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, say 12. Okay, say this is one. So look here, 5, 6, 7, 8. Only 5, 6, 7, 8 is activated. But we are selecting only the 1, because program is running for the 1. So 1, 2, 3, 4, 5. 5 is activated, 6 is activated, 7 is activated, and 8 is activated. Other are non inactivated because no input here there. But my program is there, and which pixel should be activated, which are forming a perpendicular. So perpendicular form means 1, 5, 9. If 1, 5 and 9 would be activated, then it will form perpendicular. If 2, 6, 7 will activated, then it will form perpendicular. If 3, 7 and 11 will activated, then it will perpendicular. or if this is this is 4, 8 and 12. If three are activated, then it will performing in the perpendicular, but here it is not perpendicular. So first this is the activated, then the second layer say this is the second three layer, it will calculating whether it is perpendicular form or not, whether it is perpendicular form or not. So whenever they check, no, this is not a perpendicular form, but it is forming the horizontal form, then another layer, say another layer, I am doing this in the another color. Look, in the another color, say this is checking the horizontal form, this is checking the horizon sorry, vertical formation, and this is checking the horizontal formation. In this case they also get some data, they also get some data from here. uh, Look, it is saying that yes, this is taking only the horizontal line is there, but this vertical neural checking, this is saying no, there is no formation is there which is forming the forming this type of horizon vertical line or vertical perpendicular line is there. So whenever it is output is given, say output is given, it will say no, this is not one, this is only a straight line. And how it is possible? This is checking is possible by the sigmoid curve or any other activation rules, because this is saying, say in this case, in previous case you have seen, if it is going to the pixel is activated properly, then it is one, means it is taking one. If the some portion of the pixel, some portion of the pixel is activated, then it will say when this type of voltage create. Say if the total pixel became total pixel became enlightened, then it is one. But if the some portion of the pixel is enlightened, say this is 0.2, if the half portion of the pixel is covered, then it is say 0.5. In this way it is giving some output. So whenever sigmoid curve is given, so it will any form between 0 to 1, it will treated 1. So it is also one. So if the pixel, so whenever say I am writing a writing this type of, look, in this case this pixel getting totally covered, this pixel getting totally covered, but this pixel is not totally covered. So it is given only 0.2 volt. This pixel is not totally covered, this is also covered, say point 7 volt. So how could I select this? This is coming to here. Yes, this is whenever it is come in the positive form, it will take one. So whatever it is giving. And look, this is perpendicular form. These are activated. These are activated because any point is there, it is taking, and this is also taking in the form. So in my program, if three 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 vertical pixel are activated and one any side of others, then it will treated one. So any three vertical is selected and any one is backside selected, so it is treated as a one. So it is treated as a one. In this way we can, the neural network is using the activation function, and then it will select whether it is one or any detection. And there is so many I am just going to the, don't save, I am going to the, look, guys, I think you can understand this activation functions. And now we have to learn what are the activation functions is there and how does it work. And up to this you can see now the various activation functions. First one is the linear functions. Linear functions is only able to use at the decision making layer. means just result making layer, which is actually the output layer. Output layer became the only the linear, that is y equal to x ax, just like this up to z. Look, up to the z it is wx plus b. So this is the linear function. Non-linearity is there, and this is only space at the output layer. Otherwise we never use this linear function, because if there is a linear function, then the function will not perform well for the all purpose, only few purpose. So the range is minus infinity to the plus infinity, and uses this linear activation used at just the one place, i.e. the output place. Then we are coming the sigmoid function. You have seen just the what is the sigmoid function, and the sigmoid function is that at sigmoid function is the a equal to 1 by 1 plus e to the power minus x. Okay, this is the non-linear functions, and with this, within this non-linear functionality, we can check any decision making. Okay, and then the nature is non-linear. Normally this the value is the range is 0 to 1. This is the basic decision making capacity. I just told you that. Look, another way I am showing you. This sigmoid curve, this is sigmoid curve. So if it is any value come to this, then it will select 0. Any value come to this portion, this is select 0 0 0, and any value come to this, then it will select 1. Okay, so in this way, say zero point 0.5, 0.2, 0.3, any one up to this one, this is select 1. Any value below 0, then it will negative point, then it will say 0. In this way, a sigmoid curve is used. Then and it will coming the tan functions. Okay, tan functions is that tan activation function is generally called tangent hyperbolic function. Okay, the activation that at works almost always better than the sigmoid functions, and it is tan function nothing but a sigmoid function, and it will second multiplied with 2. Look, this is the 2 divided by 1 plus e to the power minus 2x and minus 1. And this is just like a tan function is a 2 multiplication of sigmoid function. This is 2x and minus 1. A tan function is just like in this way, Okay, and uh, now it is coming the ReLU function. An example is there. It is value range -1 to +1. Okay, sigmoid function value is 0 to 1, and tan function is the -1 to the +1. Okay, and next we are coming to the ReLU function. And look, ReLU stands for, look, there is a ReLU stands for an rectification linear unit, and it is almost widely used activation functions. Okay, it is maximum a is maximum 0 and x. It gives an output x if is positive and 0 otherwise. And what is the graphical representation? ReLU function. Look, if you go for a ReLU function, this is the ReLU function. If here, and then this is the ReLU function. If there is a x, any value, any wide range, it will give 1, and if it is positive, and any value in this coordinator, in this coordinate, any value, it's remain 0. In this way, the ReLU function is given there. And there is another softmax functions. There is just like this. There is, but another portion is there. Okay, so in this way we can find the activation functions, and basis on a neuron can activate it. Say this is the neural input layer. So if it is activated, then it will pass to the message. If anyone is activated, then it will pass to the message. Then it will, this is the linear function, and this all are the non-linear functions. and then it will decide, yes, this is either one, either two, or anything you want to know. Okay, and whenever it is found that it is not one, then another program is running for the two. Then it is called the propagation. Again, from the first initial position, it will start whether it is two. If there is not two, then it will count for the program for the three. Again, it will start the taking the first initial input. Then it is called the back propagation. Okay, so this is the neural network activation functions in SCADA software, in Python, and we can watch this how this is working. And we have no assigned practical over here, but I will definitely try to show you these activation functions in your software simulation. Generally, it may be Python or MATLAB. Okay. TensorFlow is not possible here, and I will show any program after such a completion a few of this your theory portion. And guys, if you have any question, you may ask me. Okay, thank you. I am going to stop here. Only 2 or 3 minutes left. Okay, thank you.